Hello everyone, welcome to this series of science lessons. This is a continuation of the previous lecture. Scattering of light. We can categorize particles based on their size. Generally we categorize into three groups: colloids, suspensions, and solution. The intensity of scattering of light varies in these three categories. Let us take a colloidal particle. When light hit the colloidal particle, will scatter in every direction, and most of the light will pass through the colloidal particle. Here we can notice light is scattering in all direction, and also most of the light is passing through the particle. This process is known as scattering of light. When we look up and look at the sky, we see blue color. This is because of scattering of light. The red color of sun during sunrise and sunset is also due to scattering of light. These are the two well-known examples of scattering of light. There are many phenomena where we can observe scattering of light. Before we saw an example of colloidal particle. In case of solution, the path of beam of light passing through true solution is not visible. In this case also, the solution particles will also scatter the light, but the effect is too low. We cannot see the scattering of light in our naked eyes. And particles of colloidal solution are relatively larger than solution, and the particles of suspension are even more larger than colloidal solutions. Tindal Effect. In Earth's atmosphere, we can see a mixture of minute particles. These particles include smoke, tiny droplets of water, suspended particles of dust, and molecules of air such as nitrogen, oxygen, and so many other gases. When a beam of light strikes such particle, the path of beam becomes visible. We can see the dust particles in our home when the sunlight passes through the window. We can see those tiny dust particles and smoke particles. This is because of scattering of light. Those particles are scattering light in all the directions. Why is the color of clear sky is blue? Many particles which are present in the atmosphere have size smaller than the wavelength of visible light. Violet have the shorter wavelength and red color have the larger wavelength, a longer wavelength. Fine particles in atmosphere have size smaller than the wavelength of visible light. In the rainbow we can see in the visible spectrum we can see violet, indigo, blue, green, yellow, orange, and red color. When sunlight passes through the atmosphere, the fine particles in the air scatters. These fine particles present in the atmosphere scatters the light. When the sun rays are falling vertical to the Earth's surface, particles which are present in the atmosphere scatters the blue light most, blue and indigo color. They scatters all the colors, but indigo and blue scatters the most. If there is no atmosphere, the sky would look pitch black. We can observe red light is used to indicate danger signals in most situations, because red is least scattered by fog or smoke present in the atmosphere. Therefore, it can be seen in the same color at certain distance. Color of sun at sunrise and sunset. During noon, the color of sky is blue color, whereas during sunrise and sunset, the color of atmosphere turns to yellowish red or orange yellowish red. This is because this is the atmosphere. Let us take two scenarios: sun during the noon and sun during sunrise and sunset. Rays of light passing through the atmosphere during noon. Then in the second case, the rays of light passes through the atmosphere, and the rays of light has to travel longer distances during sunrise or sunset. Rays of light has to travel relatively longer distance in comparison during noontime. During noontime, rays of light travels comparatively smaller distances to a given point. Light from the sun near the horizon passes through the thick layer of air and larger distance in atmosphere. During noon, we can see particles scatters most of the blue and indigo color light. During sunrise and sunset, we can notice the color of sky is nearly orange reddish because near the horizon most of the blue light because near the horizon most of the blue light and shorter wavelength are scattered away. Therefore, the light that reaches our eyes are composed of longer wavelength. Red color, orange color and yellow color have longer wavelengths compared to violet, indigo, blue. This gives rise to reddish appearance of the sun during sunset and sunrise. The content of this recording is borrowed from Karnataka Textbook Society Bangalore under Fair Usage Policy. This video is presented by Avvari Technologies. Please do hit subscribe button to get more content. Thank you.